Okay, so now now that we can tell if a function has an inverse, how do we test if we have two different functions if they are inverse functions, right? So the question might be, hey, here's a function, here's another function. Are they inverses of one another? Okay. Well, the way you're probably thinking of is to graph them and check if all the x and y values are switched. That's great, but that has to be true for all x and y. So the only way we can make 100% sure is, well, with what we're going to get to here, okay? So for some motivation, let's use what we used earlier. We'll use f of x equals x cubed and g of x equals cube root of x. Now we saw earlier, mostly because I told you and I showed you the graphs, these are inverse functions. I will guarantee you that, okay? And here's what I want you to do is, remember, we can think of functions as machines. We put a number in, we get an output, right? And I have the directions here. It says cube the input. That's what my function f is doing. G of x is cube root the input, okay? So let's put a few of these in. If I put 2 into f of x, it gets cubed, we get out 8. If I throw that output into g of x, we cube root that, we get back to 2. Notice we got back to what we started with, right? If I use 3 and I cube it, I get 27. Put it into g of x, cube root it, I get 3. Notice that's also the same. And here, x, if I just put x in general, x goes in for x cubed. Put it in here, get back to x. This is the key right here, is that it happens for any x, okay? So this is what we talked about earlier. In fact, a function and its inverse, they undo each other. And we can see that's happening specifically here. Let's look at it in general. So suppose we're given f of x and g of x. Maybe we don't even know what the functions are, but suppose we know they're inverse functions. I want to do this in general. So if I put in 2, I don't know exactly what the directions are, but it should give me out the function value. So you could think of it as y, or you can think of it as, well, that's f of 2, right? That's the function value when the input is 2. Now I'll put that into g, okay? And we'll put it into g, and we get g of f of 2. But here's the thing. I know it's going to be 2. Why do I know it's going to be 2? Because I know inverse functions undo one another, okay? So we can kind of see that here. We see, oh, g of f of 2. It's kind of like the g and the f, they kind of go away. Now, that's not the proper way to explain it, but that's sort of what it looks like. The same thing will happen if you put 3 in. We know if we put 3 in, and these are both inverse functions, at the end, we end up with 3. And if we do it for x, we have the same sort of situation. Now, what if we take it a step further and we do it the other way? Is the inverse, if you have a function and its inverse, is the inverse's inverse the original function? That's a little wordy. Let me show you what I mean. If I put x in for g of x, we'll get out g of x. If I put g of x in, I get f of g of x, and guess what happens? I always get back to x, because if they're inverses, they undo one another. So this gives us a method to find out if we have two functions, how to find if they're actually inverses or not, okay, for sure. Let f be a one-to-one function. Then g is the inverse function of f if, remember this, our composition of functions. Fog of x, or f of g of x, is equal to x. So if they undo each other, just like we talked about, for every x in domain of g. And golf of x, or g of f of x, also has to equal x. So what I'm talking about is this part and this part both have to be true for every x in the domain of f. Now that's for every x in the domain of f and every x in the domain of g. Of course, if it's not in the domain, we don't have to worry about this, right? So let's see how we could do this. So here's an example. Determine whether the given functions are inverses of each other. So here I give f of x equals 3x plus 9. Here is g of x equals 1/3 x minus 3. So first thing I'm going to check is f of g of x. Okay. Now that's going to be 3 times g, right? I'm just putting g in wherever I see an x, plus 9. That's going to be 3 times 1/3 x minus 3 plus 9. This is going to be, let's see, if I distribute the 3, I get x minus 9 plus 9 equals x. Well, hey, f of g of x is x. That's good. I still have to check the other one, g of f of x. So what I get here is I look at g, I'll write that in, wherever I see an x, I'm going to put f. Okay, this is 1/3 times f is 3x plus 9 minus 3. Distribute the 1/3. X plus 3 minus 3 equals x. G of f of x works as well. So since both of these equal x, f and g are inverse functions. Okay, so that's how you check to see if two functions are inverses. Let's try this other one. F of x equals negative 4x plus 2. G of x equals negative 1/4 x minus 2. So f of g of x, that's going to be negative 4 times g plus 2. This equals negative 4 times negative 1/4 x minus 2 plus 2. This is going to be, let's see, negative 4 times negative 1/4 is going to be x plus 8 plus 2 equals x plus 10. So here's the problem. This is not equal to x. Just from that, I don't even have to check the other one. F and g are not inverse functions. Okay. Last thing I want to mention, and this is going to help us when we try to, so we can check if two functions are inverses. How do we actually find an inverse function if we know a function has an inverse? If f and g are inverse functions, the x's of f are the y's of g, and the y's of f are the x's of g, right? By switching these, okay? A little bit of notation we're going to use is the inverse of f, we're going to write as an f. It looks like it's an f raised to the negative 1. It's really just f inverse, okay? And we will do that here in the next video.